She was known as the Queen of the Atlantic, the Boeing 314 Clipper, the biggest plane of its time, and the first to take passengers non-stop from the USA to Europe. The onboard facilities, pure luxury.
The Boeing Clipper was virtually a flying four-star hotel.
But what happens when this legend takes on a modern-day plane icon? The Airbus A350, the most modern and environmentally friendly long-haul aircraft in our day and age. Its engines are considered to be the most efficient in the world. And in the cabin, state-of-the-art technology ensures maximum comfort.
The A350 is a quantum leap in commercial flights.
2 flying giants, 3 categories, a contest of superlatives. Category 1, construction. Which aircraft revolutionized aviation the most? Category 2, comfort. Whose passengers enjoy the greatest luxury? And Category 3, technology. Which aircraft uses the most innovative systems? Now, in Legends versus Modern Icons. USA, Seattle, home of the aircraft manufacturer Boeing. In the factory on the Duwamish River, the legendary B-314 was built from 1936. The aircraft's dimensions were, for the time, gigantic. The plane was 32 meters long and had a wingspan of almost 47 meters. Its range of 5,900 kilometers was more than any other passenger aircraft of the time. The cabin could seat 74 passengers, an absolute record at the end of the 30s.
With the B314, Boeing has achieved an engineering masterpiece.
But how does the legend compare with a modern-day icon of the air? France, Toulouse, headquarters of the aircraft manufacturer Airbus, and the birthplace of the most modern passenger plane of the 21st century. The Airbus A350, available in several versions. Its longest version measures around 74 meters with a 65-meter wingspan. The ultra-long-range version can cover 18,000 kilometers in one go, more than any other twin-engine passenger aircraft. Maximum capacity is 480 passengers.
The A350 is based upon the most recent developments in aircraft construction.
The Boeing B-314 versus the Airbus A350, a contest of superlatives. We begin with the category construction. Round 1. Which aircraft design is the most revolutionary? Humans have always dreamt of flying. In the 20th century, it became a reality. Some 20 years after the Wright brothers lifted into the air in 1903, the golden era of aviation began. Technical advancements made it possible for the first time to build passenger aircraft. The non-stop transatlantic flight was the major goal of every airline because it promised huge business.
Every airline wanted to be the first one to secure the transatlantic route.
In the mid-20s, 1 million passengers a year traveled between America and Europe by ship. Almost 1 in 5 of these went first class. They had plenty of money, but little time. Ideal customers for expensive luxury flights the world had yet to see. In February 1936, the American airline Pan American Airways Systems, Pan Am for short, put out a tender for a large aircraft.
The requirements for the new aircraft were just too unrealistic for those times.
It was to have space for around 70 passengers and a payload of 4.5 tons. Fully loaded, it was to have a range of at least 5,500 kilometers. For the best design, Pan Am was offering a prize of $50,000 US, almost $1 million in today's terms. One who took up the challenge was the aircraft manufacturer William Boeing, together with his young engineer, Wellwood Beale. The first big problem they faced: existing runways were too short for an aircraft of these dimensions. Therefore, they opted for a flying boat. All it needed was a sheltered bay to take off and land.
A flying boat could fly to almost any coastal city in the world.
Their concept: a gigantic floating body as a fuselage, combined with state-of-the-art wings from a military experimental aircraft, plus the latest and most powerful engines of the time. And the concept convinced. In the summer of 1936, Boeing began construction of the first version of the 314 Clipper. At the time, the world's biggest and most powerful passenger aircraft. After World War II, range and passenger volumes constantly increased. In the 1960s, aircraft finally became suitable for mass transport. Bigger and faster was the motto of aircraft manufacturers and airlines. Major highlights during this developmental phase were aircraft such as Concorde and the Boeing 747.
Today, the trend in aircraft construction is moving away from this. The aim is to build aircraft with an extremely long range and also extremely economical.
When Airbus engineers in 2004 began working on a concept for a new long-range jet, they had a clear goal in mind. In design and efficiency, it was to outshine all other aircraft. The engineers first focused on materials. Instead of building the fuselage from aluminum and metal composites, as a lot of existing airplanes, they used carbon fiber reinforced plastic, in short, CFRP.
The advantage of the material is that it is light, elastic, and extremely stable.
To maximize space inside the aircraft, engineers opted for a round fuselage. The cabin sides are then steep, giving passengers more space. The engines had been completely newly developed. These were specially adapted to the A350's flight characteristics. The aircraft consumes just 2.9 liters per 100 kilometers per passenger, less than any other passenger aircraft. When the Airbus engineers presented their final design, the clients were ecstatic. More than 550 orders had been submitted by the time production started. A complete success. Time for an initial verdict. Both legend and modern icons set new design standards, with the Boeing 314 Clipper appearing to be slightly more revolutionary. Round 2 in the construction category. Which aircraft has the most groundbreaking construction? A major challenge for the Flying Legends engineers was that the Boeing Clipper not only needed aircraft characteristics, it also had to sail like a ship. The enormous fuselage of the B-314 was therefore shaped like a boat.
But the fuselage shape had a disadvantage. It was not particularly aerodynamic.
To keep dimensions to a minimum, engineers fitted the flying boat with sea wings, small stubby wings on the sides of the fuselage, which stabilized the flying boat in water and also served as fuel tanks. To save weight, the engineers opted for an all-metal design, a technology that was still relatively new at that time. In 1919, the first civil mass-produced plane, made entirely of metal, made its maiden flight, the F-13 from Hugo Junkers. A passenger plane with space for 4 people. But the concept of all-metal aircraft was only slowly gaining acceptance.
Many simply could not imagine that an airplane made from such a heavy material as metal could fly reliably.
The metal construction was ideal for a flying boat. Especially in water, metal is much less sensitive than wood. The Boeing Clipper used steel frames as kind of cross struts. Longitudinal stringers ran across them, providing additional strength. Additional struts and supports for even more stability were fitted into the interior layout of the aircraft. The aircraft's steel skeleton weighed just 2 tons, an absolute lightweight for the time. Technicians covered the frame with aluminum. Tens of thousands of rivets were placed by hand to hold the gigantic aircraft together. At the hull, cement and neoprene tape ensure that no water penetrates. The time had arrived. On the 19th of June, 1938, just 2 years after concluding contracts, all the technical skill and ingenuity proved their worth. The Clipper's maiden flight was successful. Over the next years, 11 more aircraft would be built. When building the modern Icon, its designers also used the very latest materials and production methods. 53% of the aircraft is made up of CFRP, more than any other aircraft built so far in the world.
With its high-tech materials, the A350 is considered a pioneer in the aviation industry.
The foundation stone for the high-tech material of the modern Icon laid the inventor of the light bulb, Thomas Edison. He was seeking a material as a filament that could combine electrical conductivity with flexibility and robustness. After extensive research, he found it in a Japanese type of bamboo whose fibers he carbonized through heating. But CFRP remained undeveloped until almost 100 years later. In the 50s, the space race led to research into new, lightweight, yet robust materials. Carbon fiber production on an industrial scale became possible for the first time. By embedding hair-thin layers of carbon fibers in synthetic resin, the miracle material CFRP is created. The fuselage of the A350 is built in 3 long sections, which are later assembled with millimeter precision. The individual sections consist of so-called panels: the crown, the keel, and the 2 side panels with the windows. The panels are up to 20 meters long. The advantage of the construction method: the low number of transverse seams and the longitudinal seams of the panels running across the entire aircraft further increase the stability of the fuselage.
Another advantage of the panel concept is that in the event of damage, only the affected part needs to be replaced, not a whole section.
In June 2013, 9 years after the first drafts, the A350 takes off on its maiden flight. It was an all-round success. The engineers of both the Boeing Clipper Legend and the A350 used construction methods unique for their time, taking aviation to new levels. Round 3 in the construction category. Which aircraft's wing concept is more innovative? The wings of the Boeing Clipper Legend were based on the recently designed experimental XB-15 aircraft. At that time, the bomber was the biggest and heaviest aircraft ever built in the USA. It never progressed from being a one-off prototype, but the equally legendary B-17 was to be created later, based on the XB-15. The Clipper used practically unmodified versions of the XB-15's giant wings. The wings were over 1.5 meters thick. Compared to today's planes, the wings look like huge slabs. But in the 30s, such a wing design was the only way to get an aircraft of this size to fly. While modern wings are elastic, so they won't break, even when subjected to high forces, metal wings back then were stiff. A large cross-section was required to prevent them buckling under loads.
The wings of the Boeing Clipper were so large that the engines were reached by a passageway.
A groundbreaking concept for the time. As engines became more powerful, aircraft speeds also increased, and the old wing designs lacked the required aerodynamics. Over the decades, engineers developed many new concepts, pushing efficiency to new heights. One wing shape has now become widely adopted: the swept wing. The stronger the wings sweep, the less flow resistance at the wing's front. Air flows easier along the wing, and the aircraft is able to fly faster. Designers of the iconic A350 opted for a high sweep of 35 degrees. This gives the aircraft very good aerodynamics at high speeds, enabling it to reach a cruising speed of over 900 kilometers per hour at extremely low fuel consumption.
The state-of-the-art wings are a key factor in the engineer's ability to reduce fuel consumption by 25% when compared to other long-haul aircraft.
Curved wing tips, called winglets, optimize airflow to give improved uplift and reduced fuel consumption. This idea was copied from birds of prey half a century ago. These birds use their fanned wingtips to glide slowly in the air in search of prey. Airbus engineers perfected the principle in the A350 by using the latest aerodynamic findings.
Another advantage of the winglets is that they reduce the noise level of the aircraft.
Thanks to its carbon fiber composites, the wings are extremely elastic. The 32-meter long and 6-meter wide wings can sway up and down like the wings of a bird, optimally adapting to aerodynamic conditions. There is no risk to passengers. In tests lasting several hours, the wings were moved 5 meters upwards and downwards with no evidence of cracking. Although the Boeing 314 wings impress with their unique size for the time, they cannot compete with the ultra-modern wings of the A350. Verdict in the category design. With its innovative design, the Legend revolutionized aviation. The modern icon, on the other hand, impresses through its ingenious application of current-day know-how and state-of-the-art materials. We now continue with the comfort category. Round 1. Which of the two contenders gives its passengers more space and room to move? The Boeing Clipper's cruising speed was almost 300 kilometers per hour. To fly from Europe to America, therefore, took more than 20 hours. Ticket prices were comparable to those of a luxury cruise. A one-way flight from Foynes in Ireland to New York cost $375 US, the equivalent today of $7,000.
In the B314, there was only one seating class, namely first class, After all, only rich people could afford to buy tickets, and they expected a certain luxury.
The Flying Clipper had 2 decks. The lower deck was reserved for passengers. Rather than sitting in rows, one behind the other like today, passengers sat in compartments. The passenger deck was divided into 11 areas. 5 compartments with 10 seats each. The galley, a spacious dining room, an exclusive compartment with just 4 seats, 2 dressing rooms with toilets, and a bridal suite.
A bridal suite on an aeroplane, that has never happened before or since.
Passengers had to remain seated only during takeoff and landing, and could otherwise move around the aircraft as they wished. This was a completely new flying experience. The luxurious interior made the huge flying boats famous all over the world. Can a modern plane compete here? After the Second World War, technical advancements enabled aircraft to become increasingly larger and more powerful. To fully utilize aircraft capacity and attract more customers, airlines adopted the class principle from the large transatlantic ships. Economy class was invented.
This was a complete success. Within 3 months, the passenger volume of airlines offering the new class increased by 30%.
Competition between airlines is now huge. If you want to cross the Atlantic, you need only around 6.5 hours. And you also want to pay as little as possible. The A350's challenge. To maximize space for passengers and to fully utilize the aircraft's capacity. To achieve this, engineers used a whole package of innovations. The round shape of the fuselage makes sides in the passenger cabin almost vertical and enables full use of the cabin's 5.61 m width. With 9 seats per row, each passenger has 48 centimeters of space. No comparison to its legendary competitor, but significantly more than in most other modern passenger planes. The second factor for more comfort is, again, the Wonder Material CFRP. Thanks to its extreme strength, engineers can make the windows a good third larger than those of many other modern airplanes.
The huge windows make the cabin look bigger and just overall enhances the feeling of space.
Such clever tricks by the aircraft designers have succeeded in ensuring that passengers have, by today's standards, plenty of room. But it is still incomparable to times past. The modern icon does not stand a chance against the Legend's amount of space and freedom to move around. Round 2 in the comfort category. Which aircraft has the more impressive onboard offerings? One of the top highlights on board the Legend was the food. Instead of eating from a tray at their seats, like today, passengers on board the B314 went to a separate dining room. In small groups, they were served a 6-course menu. The food was prepared by star chefs and then prepared on board by the stewards.
The tables were set with linen, and the food came on real Chinese porcelain.
Watching blockbuster movies like today was, of course, not yet possible. With Disney's Snow White and the Seven Dwarfs, color films had celebrated their breakthrough just a few months before. The first regular film screenings in airplanes have only been taking place since 1961. Passengers on board the Flying Legend instead leisurely passed the time with philosophizing, reading, playing cards, and parlor games. Spacious bathrooms were available for calls of nature, hot water included. An ingenious system provided the hot water. A hydraulic pump in one of the 4 engines pumped glycol, incidentally still used as a coolant in cars today, into a boiler inside an exhaust pipe behind the engine. The exhaust gases heated the glycol, which flowed into a heater to warm the water. The hot water then flowed through a sophisticated system of pipes to the bathrooms and galley.
Having hot water on board was the icing on the cake of this luxurious equipment.
The unique range of onboard facilities meant the Clipper was also known as the Flying Hotel. Unbeatable aircraft offerings, or perhaps not. The modern Icon also aims to entertain passengers on flights taking up to 19 hours. The ideal way to do this is with an onboard entertainment system. 11.6-inch full HD displays are available for movies, series, and games. They can also be used to watch your own movies via USB.
In the meantime, some airlines even allow passengers to put together their own in-flight entertainment package before they get on the aeroplane via an app.
Wi-Fi is also standard in the A350, thanks to an extra powerful antenna in a dome on the fuselage. At an altitude of over 3,000 meters, servers inside the plane connect to satellites. These share signals with ground stations connected to the internet. Passengers are then able to access the network of wireless access points. Even the most modern aircraft cannot provide dining rooms for the mass of current-day passengers. The standard practice now is to simply place pre-cooked meals into a steamer. When it comes to taste, the airlines themselves are in demand. Some of them test meals in a compression chamber to simulate conditions during a flight. At lower pressures, taste and smell senses are poor, similar to having a cold. Meals, therefore, need to be spicier. Verdict: even when the A350's entertainment is good, the modern Icon is far behind the legend for onboard services, especially regarding food. The final round in the comfort category. Which plane has the better features? Compartments that can be converted into bunks is a special feature on board the B314.
Of course, the guests didn't have to do it themselves. This was the job of the stewards.
Designers took the idea from railway sleeping cars. 2 armchairs could be converted into a bed. Fold-down bunks were also available to create a type of loft bed. Curtains ensured maximum privacy. However, the B314 only had 36 berths. The reason why the aircraft, which actually had room for 74, were only ever half booked on transatlantic flights. Every passenger was to have a berth. The luxurious and unique facilities in the 314 Clipper destined it to become the world's first presidential aircraft. In 1943, Franklin D. Roosevelt, then President of the USA, traveled in one of the legendary flying boats to the Casablanca Conference in Morocco, a secret meeting of the anti-Hitler coalition. In the 21st century, things look different. No wonder when 71% of seats in a modern aircraft, such as the A350, are in economy class. Passengers here can only dream of stretching out to sleep. Seats can be reclined only by a few centimeters. The only way to impress here is again through state-of-the-art technology, such as the mood lighting system. lighting in the cabin can create over 16 million different colors, simulating different lighting moods, sunrise and sunset included. This helps to keep passenger biorhythms as balanced as possible and reduces jet lag.
A second decisive factor in ensuring that passengers leave the aircraft rested is the cabin ventilation.
Air in the A350 undergoes complete renewal every 2 to 3 minutes. The engines suck in fresh air for this purpose, so-called bleed air. As the ozone levels are higher at high altitudes, the ozone is filtered out, the air is cooled down, and mixed with purified cabin air. The cleaning filters for the cabin air are the same as those used in operating rooms. The cabin air is not only extremely fresh, but also 15% more humid than in any other aircraft. Mucous membranes won't dry out as much, and passengers feel fitter.
Here again, CFRP plays a key role. It can cope with much higher levels of humidity.
Artificial sunrises and an ultra-modern ventilation system mean even economy-class passengers in the A350 arrive refreshed. But in a direct comparison, the flying boat with its beds remains ahead. Time for the verdict in the comfort category. And it's pretty clear. Despite its state-of-the-art technology, against the Legend's luxury, the modern icon doesn't stand a chance. But then, ticket prices for the Legend were horrendously expensive. Time for the third category in the contest between the aircraft giants, technology. First, which of the two contenders has the better flight control and navigation systems? At least a 5-man team was needed to fly the gigantic flying boat safely across the Atlantic. 3 pilots, a navigator, and a radio operator. All crew members had naval ranks because Pan Am President Juan Trippe called his flying boats clippers, after the famous clipper ships that transported freight and passengers across the Atlantic in the 19th century. To add to the maritime flair, the crews wore navy blue uniforms and were referred to as captain, first officer, or steward. Titles have held their own in aviation to this day. In the front of the plane were the pilots, the captain and one of his 2 officers. Their task was to control the plane. The radio operator was responsible for contact with ground stations. Wireless communication at the time worked only over very short ranges. Communication was therefore via Morse code. Receiving the latest weather reports was vital. At a maximum altitude of 3,000 meters, the flying boat was much more exposed to storms than today's aircraft, which fly almost 3 times as high.
Navigation on the B314 worked like on a ship.
Information on flight direction came from the navigator. GPS and radar were not yet invented, so navigation aids were maps and a sextant. At the beginning of the 18th century, the sextant revolutionized positioning at sea. It enabled legendary figures, such as James Cook, to undertake spectacular expeditions. The navigator used a sextant to measure the angle between the horizon and celestial bodies, such as the moon, stars, or the sun, recording also the exact time at which the measurement is taken. The data is then checked against a table of codes to give a position. The B314 had a glass dome on board, the Astrodome, giving a panoramic view of the sky.
The biggest problem, however, of the Clipper was that it only flew at an altitude of 3,000 meters, that is, below cloud height. That means you could go the entire duration of the flight in the clouds and never see the stars.
One of the navigator's tricks in poor visibility, small flags attached to the wingtips enabled navigators to assess crosswinds and calculate how much counter-steer pilots needed to apply to continue flying straight ahead. Thanks to sophisticated navigation techniques, flight crews took the flying boats safely to their destinations, even under adverse conditions. Bringing the modern Icon safely to its destination now only needs a pilot and co-pilot. The rest is performed by computers. The Airbus A350 has, in addition to standard systems such as autopilot, many other tools to make flying even safer and more efficient.
The cockpit of the A350 is one of the most modern in the world.
One of these systems is the automatic weather radar. While pilots in other aircraft need to repeatedly call up and check weather radar, the A350 system reports as soon as a storm appears on the planned route. Pilots then have time to choose an alternative course. Another system is BTV, brake to vacate. Before landing, pilots enter the taxiway to be used to vacate the runway. BTV then brakes the aircraft exactly according to this input.
Such assistance systems provide additional safety and minimize wear and tear on the aircraft.
Pilots also have head-up displays. On semi-permeable fold-down mirrors, they see important flight data, such as horizon line, course, altitude, and speed. Thanks to this, they can keep a constant eye on the surroundings. For the future, the aircraft manufacturer is planning to enable the A350 to take off and land fully autonomously. Initial tests have already been successful. More advanced technology is hard to imagine. Verdict: despite the Legend having the first autopilot, the modern Icon is ahead in terms of flight systems. The next round in the technology category: which aircraft had the most efficient engines for its time? When Boeing engineers were planning the B314, they knew that to get the gigantic flying boat into the air required engines more powerful than any that had gone before. Their choice fell on a new development from the Wright-Curtiss Company, the Wright R2600.
Wright-Curtiss had developed these engines together with the American military.
The engine had 14 cylinders, each with a capacity of around 30 liters, delivering an impressive 1,600 horsepower. In comparison, cars at the time had an average of just 30 to 50 horsepower. 4 of the new powerful aircraft engines were mounted onto the Boeing Clipper. They each drove a steel propeller with a diameter of 4.5 meters. The Boeing 314's powerful engines meant it could reach a maximum speed of 320 kilometers per hour.
The power of the engines was so strong that the aircraft could fly with only 3 engines in an emergency.
But the engines required constant monitoring. Every flight therefore had minimum 1 engineer on board, who could control each engine individually via a panel. If an engine overheated, the engineer could direct more air through an outer flap to cool it. The flight engineer was even able to access the engines via a passageway in the huge wings and make repairs during the flight. The extremely powerful engines made the B314 the fastest and most reliable passenger aircraft of its time. But propeller engines, such as the ones of the B314, have their limits.
The problem is that if the propellers rotate too fast, the airflow stops and they become inefficient.
This limited the speeds of such aircraft. No problem for a passenger aircraft, but the military required faster planes. At the end of the 30s, the Englishman Frank Whittle and the German Hans von Ohain therefore began independently researching a new type of engine, the jet engine. From 1942, the first series-produced jet-powered aircraft began flying. initially only as military aircraft, such as the Messerschmitt Me-262. After the Second World War, the new engines began to be used also for civil aviation. In the course of time, these engines were developed into the aircraft engines of today, known as turbofans. They are more fuel efficient and quieter. The A350's engines were specially developed for the new aircraft and are among the most efficient and quietest in the world.
Fuel is the biggest cost item for an airline today. In addition, airport fees are often calculated upon the noise level that an aircraft makes. This makes the engine the decisive cost factor in constructing an airplane.
The manufacturer Rolls-Royce spent 9 years developing the new Trent XBW engine. It has a diameter of 3 meters and delivers the equivalent of more than 50,000 horsepower. 2 are mounted on the A350. The inlet propeller, called the fan, consists of 22 titanium blades and sucks in more than a ton of air per second.
This amount of air is sufficient to fill an entire stadium in about 2 minutes.
The sucked-in air divides into 2 streams inside the engine. The inner air stream is compressed, flows into the combustion chamber, and is mixed with kerosene and burned. The hot air stream spreads quickly and drives several turbine stages. A 3-shaft principle ensures optimum speeds. The external airflow, which accounts for around 90% of the Trent XBW, is directed around the core engine and accelerated in the exhaust nozzle. The increased speed at the exit provides a major part of the thrust and makes the engine around 15% more efficient and quieter than any other. The newly designed engines enable the A350 to achieve a top speed of 960 kilometers per hour, while consuming an extremely low amount of fuel. Verdict: both legend and modern icon can claim to have the most powerful and efficient engines of their time. Time for the final comparison. Which plane is safer? When Boeing began building the new flying boat in 1937, one of the biggest aviation disasters of the time happens in New Jersey. The Hindenburg airship disaster. On landing, a hydrogen tank ignited. The Hindenburg crashed uncontrollably to the ground and burst into flames.
The crash of the Hindenburg shocked the world, and to this day, the cause is not clear without a doubt.
Shocked by the accident, Boeing made even greater efforts to make the B-314 as safe as possible. The fuselage had a double-floor design, like a ship, in case the Boeing collided with an obstacle during takeoff or landing. The raised floor, in turn, was divided into 10 separate cells. Watertight bulkheads prevented the entire aircraft from filling with water and sinking in the event of an incident. 2 pumps were also installed in each bulkhead to keep water levels in an emergency as low as possible for as long as possible. This lower fuselage section, designed as a boat hole, made the flying boat virtually unsinkable in the event of ditching.
Towards the end of World War II, when a severely damaged plane had to be sunk during a towing maneuver, the Navy had to put 1,300 rounds into it before it sank.
Each passenger had a life jacket under their seat. Additionally, there were 8 lifeboats. For emergency exit, the windows of the passenger compartments were used. They were located close to the water surface so that exit would be relatively easy. All materials used in the aircraft were also fireproof.
Whether seats, tapestries, or tablecloths, each piece has been tested for fire resistance by a specialized institute.
And the measures paid off. The Boeing 314 was the safest aircraft of its time. Despite the millions of kilometers flown, only one heavy crash occurred in a failed landing incident. The modern Icon's engineers also did everything they could to make the aircraft safe. To put the new materials used in the A350 through its paces, prototypes had to pass many stringent tests.
During such tests, aircraft are exposed to loads many times higher than those encountered in normal flight operations.
The toughest were the cold tests. For example, engineers in Norway investigated how the A350 behaved at temperatures as low as minus 40 degrees Celsius. During test flights, test pilots took the aircraft to its maximum limits with extreme maneuvers. They also tested how long the plane could remain in the air with only one engine. The result was an impressive 7 hours.
This ensures, on all routes around the world, that an A350 can reach an airport in case an engine fails.
The A350 has 4 emergency exits in case of evacuation. One directly behind the cockpit, one in front of and behind the wing, and one at the end of the aircraft. The special feature, 3 of the 4 emergency exits have a double evacuation slide. This allows passengers to leave the aircraft even faster in an emergency. The A350 is among the 9 types of aircraft that have never crashed since 1959. In terms of safety, both Legend and modern Icon set new standards. In the event of emergency ditching, you would even be safer in the historic flying boat. The verdict in the technology category. In terms of flight systems and engine efficiency, the modern Icon leads. But on safety, the Legend can definitely keep up. They are both milestones in aviation history. The Boeing 314, the largest and most powerful passenger aircraft of its time. And the A350, the world's most modern and environmentally friendly long-haul aircraft. Whether in design, comfort, or technology, both Legend and modern Icon set new standards in aircraft construction.